face of deadly radiation, raging sunstorms, and asteroids the size of Mount Everest, robot space probes are opening up a whole new frontier of exploration for humankind. Right now, millions of miles away in deep space, probes on Mars and on Saturn's moon Titan may be on the verge of answering one of our most fundamental questions. Could life exist on other worlds? Since the dawn of the space age in the 1950s, man has sent over 200 robotic probes into space. Millions or even hundreds of millions of miles from home, these astonishing machines are our eyes and ears in space. Orbiting other worlds, landing on alien moons, probes have shown us the universe up close and personal. They have brought back samples from moons and comets, and even the sun itself. These are delicate, super sophisticated machines, yet they must survive the brutal battering of launch, the savage cold and radiation of space, all to help science solve the great mysteries of our solar system. Each generation of probes is more sophisticated than the last. Now, decades of design and experiment have culminated in the two most ambitious probe missions ever, set to explore the two worlds in our solar system that most resemble our own planet Earth. Mars, cold, almost airless, and flooded with deadly radiation. Yet this is one of the few places we might find liquid water, a vital ingredient for life as we know it. But safely landing two large and delicate rovers on the surface of an alien world, after a journey of nearly 300 million miles through space, is a near impossible challenge. And then Titan, Saturn's largest moon, so cold that its rocks are made of water ice, and its rivers are liquid methane. Titan closely resembles Earth billions of years ago. Reaching this mysterious world requires a 7-year journey, passing through the asteroid belt, and an encounter with Saturn's deadly rings. Scientists hope that somewhere on these worlds, they may find clues to answering mankind's most fundamental question: is there life elsewhere in the universe? NASA's plans to send 2 rovers to Mars got underway in the year 2000. Their mission: to spend 3 months exploring the red planet's surface. The mission's principal investigator, Professor Steve Squires, has dedicated 16 years of his life to making this ambitious mission a reality.
I had absolutely no idea how rough it was actually going to be.
A lot rides on this mission. 2 previous probes to Mars have failed. The first was planned to orbit around the planet. It missed and burned up in the atmosphere. The cause, a mix-up between English and metric units. Then, just 10 weeks later, they lost its sister probe.
Our mission arose from catastrophe. We had 2 missions that preceded us, Polar Lander and Climate Orbiter, that were both lost at Mars.
Squires' project is mission almost impossible. He has just under 3 years to build and launch 2 new rovers.
Either we were going to go to Mars when we did, or we probably were never going to go at all. And so we had this absolutely inflexible deadline.
The schedule is seriously tough, but the real challenges are technical. The probes must survive a bone-shaking launch, a 7-month flight, and then hit a re-entry window just 4 miles across, traveling at 12,000 miles per hour. In the atmosphere, a complex parachute system will decelerate the probes to just 12 miles per hour. They will literally bounce to a standstill using a series of airbags. Only once the protective casing opens can their mission begin. To design and build 2 Mars rovers from scratch in just 3 years is an incredible challenge. But the engineers have one big advantage. 3 years earlier, when 2 Mars missions failed, one other mission, Pathfinder, succeeded. Pathfinder was the first roving vehicle to have been safely delivered to another planet. It didn't travel far, but proved it could be done. The 2 new rovers are scaled-up versions of the original. But there's a problem. The rovers get scaled up and up. More and more instruments get added. A panoramic camera, sophisticated geological tools, a microscope, then large solar panels to power it.
When we actually got down to the business of stuffing it into the lander, it was about 10% too big. It wouldn't fit in the lander.
The team set to work to build a bigger craft to transport the rover through space to its final destination. Next, the rovers themselves must prove their worth. After 2 years of intensive design and assembly, the team get their first chance to see them in action. After so much struggle, it's an emotional moment.
To actually see a fully assembled rover come to life for the first time brought tears to my eyes. I mean, I try to be the, tough space explorer guy, but that was just too much. That was an overwhelming feeling.
This is the Sandbox, a simulation of Martian terrain at NASA's Jet Propulsion Labs in California. To collect the samples and images the team needs, the rovers must travel miles over a harsh terrain of dust and rock in temperatures as low as minus 190 Fahrenheit. Key to their survival is an innovative wheel design that should help protect the rover's delicate instruments. The spokes have a unique spiral pattern to absorb shock. They are made from a special material called solamide, which can flex at extremely low temperatures. Cleverest of all, rather than using springs, the rover bends at its joints like human limbs. This allows the probe to climb over rocks bigger than the diameter of its own wheel. With the rover's design now set, the team at last knows how much the vehicle will weigh. With just 7 months left, it's time to finalize the design of the parachutes. They must be capable of opening in the thin Martian atmosphere at supersonic speeds. Lead engineer for this phase of the mission is Adam Stelzner.
At about 1,000 miles an hour, we open up the parachute. The parachute takes us down to a couple of 100 miles an hour.
The parachute is a disc gap band design with 2 key parts. The upper part, called the disc, inflates to the shape of an upside-down bowl 30 feet across. This provides most of the drag. The band suspended below the disc helps to stabilize the system. The design must be perfect, and for that they need to test it. The trouble is that simulating the immense speeds that occur on entry to the Martian atmosphere simply isn't viable. To compensate for these lower speeds, they must add an 8,000-pound weight, 4 times heavier than the actual spacecraft. The system must work perfectly, first time, 100 million miles from home. The test weight was lifted to around 3,000 feet by a Chinook helicopter.
The first big full-scale parachute test. We feel very confident, everyone's good, it's a beautiful day.
On the ground, the engineers watch confidently as the helicopter releases the giant dart. Then, disaster. The parachute shreds dramatically. It will never be strong enough to use on Mars.
There's a pit in your stomach. You're trying to search through your mind as to what went wrong.
They can't increase the size or strength of the parachute. With every pound of weight a premium on the spacecraft, it needs to fit inside a 10 by 17-inch bag. So they create 3 new designs, with different fabrics and different sized discs and bands. To save time, they test them in the biggest wind tunnel in the world, housed at NASA's Ames Research Center in Northern California. Huge fan turbines simulate high wind speeds by sucking air through the vast chamber. With the turbines on, the newly designed parachute is fired from a mortar. This time, the parachute fails to open properly, flapping half open, half closed, an unusual phenomenon called squidding. It's unexpected and disastrous. After the test, they discover the problem. The main vent hole at the top is bigger than it should be. With time running out, they shrink the hole by hand and try again. At first, it begins to squid, but then suddenly, it opens. At last, they have a parachute that can slow the spacecraft in the thin atmosphere of Mars. By May 2003, the rovers and spacecraft were nearly ready for launch. But then a problem develops that threatens the whole mission. Small bolts and cables hold the rover in its traveling configuration. Now, just weeks before the launch, the team discover that the small explosive charges designed to release those bolts may be faulty.
They're little explosive devices that cause a solar panel to deploy or an arm to deploy or something that allow these things to separate from the vehicle.
If the pyrotechnic system malfunctions, the whole mission could be a write-off. Timing of discovery couldn't be worse. There are just days to go. The rocket is already on the pad.
This could threaten the whole mission. If we're not able to launch these things now, it may not make sense to ever fly them.
It's the biggest race of their lives. May 2003. After 3 years of preparation, the Mars rover Spirit is ready for launch. But at the very last minute, a technical problem could force the mission to miss its launch deadline. The design team have discovered that the pyrotechnic cable cutters that release the rover when it reaches Mars may be faulty. They can't be sure without checking. But at this late stage, opening up the rover is impossible. There is only one solution: to track down the fired pyrotechnic cable cutters used during the testing phase to see whether they were flawed. If the old ones are functional, then the team can be confident that the new ones on the rover are functional too. Kobe Boykins, a mechanical engineer, was involved in the hunt for these old pyros.
Some were at the lab here at the Jet Propulsion Laboratory. Some were at the Kennedy Space Center. Some were put away in closets. Some tests were done early enough that those pieces had been removed from the rovers early on in testing and put in a box, and that box was put in a cabinet.
With time running out, the engineers tracked down dozens of old pyros, each one being tested for the fault. They all passed. And just as they were fueling the second stage of the rocket on the launch pad, the last pyro was discovered. NASA gave the go-ahead for launch.
It went right down to the wire. There were many, many times during the development of our spacecraft when I didn't know if we would make it. I mean, 3 days before launch, I didn't know if we would make it.
Then, at last, the moment Steve Squires has dreamed of for 16 years. The launch of the two most ambitious probes ever sent to Mars, Opportunity and Spirit. Their time has finally come. First to go is Spirit.
Standing there on the beach in Florida, I didn't know if we had done enough or not. I didn't know if these things were going to die before they did their jobs.
Launch is a risky process. Millions of dollars of complex engineering can be obliterated in an instant.
There's anxiety, there's anticipation, there's like excitement, happy excitement, and dread. It's all balled up.
The probes sit on top of almost 10,000 gallons of highly explosive rocket fuel. A rocket is essentially a controlled bomb. no launch could ever carry a safety guarantee. As the countdown begins, the engineers wait nervously.
15. Let guys go. And hydraulics go.
Gotta remember to breathe. Gotta remember to breathe.
The moment up to the point where they actually light the rocket, where the fire actually starts, you're sort of sitting there and it's sort of quiet anticipation. You're just ready for it to go.
T-minus 10, 9, 8, 7, 6, green board, 5, 4, 3, 2, 1. Hit start and liftoff of the Delta II rocket carrying the Spirit from Earth to planet Mars.
Load relief kit crate is in, vehicles responding. Vehicles recovering very nicely from the liftoff transients. We're approaching Mach 1.
It sounds silly. I mean, it's a robot. It's a piece of metal, right? It's not a human being by any stretch. But you develop this sort of intense feeling for them, and then, man, you put the thing on top of a rocket, and it's gone. And you realize, I'm never going to see this thing again.
And we're out there hoping it's going to go, hoping it's going to go. Boom, it goes. Glorious, you know, because it's thundering. Continual rolling thunder, the likes of which you've never heard.
A month later, Squires watches with his family as Opportunity joined its twin, Spirit. Together they begin their epic journey to Mars. But why do we keep going back to the Red Planet? The answer is water. Older probes in orbit around Mars have revealed telltale signs of ancient water erosion on the Martian landscape. Gullies, riverbeds, perhaps even oceans. And where there's water, there might just be life. The signs are unmistakable because they also appear on Earth. Planetary geologist Professor Phil Christensen studies how water erodes our planet's surface.
From orbit, we can look down from above and see the entire planet. So just like in a helicopter, you get a totally different view than if you're down walking on the surface.
This aerial view shows clearly how water erosion carves the features that you see in Arizona today.
On Mars, the landscape is very similar to this. Some of the canyons form by very rapid floods, where canyons larger than these can form in a matter of days.
On Mars, these features formed millions or even billions of years ago. They raise a tantalizing possibility. Both rovers will land in areas that might once have been lakes. Their mission is to learn more about the way water may have shaped the Red Planet. They may even find clues that will help future missions solve the biggest question. Has life in some form ever existed on Mars? First, the rovers need to get there. They must complete a dangerous trip through space of almost 300 million miles. The first 3 months of the journey to Mars goes as planned. Then, Mission Control receives some alarming news. Scientists at the U.S. Space Environment Center have just recorded a massive burst of solar radiation from the sun. A solar flare bigger than any witnessed in history is on its way toward the delicate probes. Solar storms are deadly. They can knock satellites back to Earth and even fry electrical grid systems.
The biggest solar flare in recorded history happened while we were on our way to Mars. It's just the kind of luck that we had with this mission. If there could be plagues of locusts in space, it would have happened to us.
The probes navigate by recognizing star patterns. Squires and his team fear that the bursts of solar radiation will be interpreted as stars by the probe's navigation system. This could be disastrous. The probes could go off course and never make their rendezvous with Mars. To solve this, the mission controllers switch to a backup navigation system that uses the sun itself. Their other worry is that the solar flare will damage the probe's computer memory. All the team can do is wait. After the storm has passed, the team reboot the computers to check for damage. To their enormous relief, the memory is intact. The probes have survived the biggest solar flare ever recorded.
It turns out that our spacecraft was more robust than most.
After almost 300 million hazardous miles, the first probe, Spirit, now faces the most dangerous part of the mission, landing. It's relying on yet another novel technology, airbags. These will envelop the whole craft and cushion its landing. Re-entry and landing is the shortest phase of the mission, yet a single failure, a single miscalculation, and the entire mission is a write-off.
You hit the top of the Martian atmosphere going 25 times the speed of sound. 6 minutes later, you're on the surface. It's a hell of a ride.
It's been called the 6 minutes of terror.
On January 25th, 2004, the spacecraft hits the Martian atmosphere 20 times faster than a speeding bullet. Friction slows it to just 900 miles per hour. It's time for the parachute to deploy. But has it opened correctly? In mission control, they nervously wait for a signal. Minutes pass. Then, at last, a faint signal. The lander is now descending on a cable, hanging below the entry vehicle. Next, they must wait for the airbags to deploy and stay intact.
It has to be able to take an impact at freeway speeds running into a pile of rocks.
Finally, seconds before landing, reverse rockets will fire to soften the impact. Once again in mission control, they wait for a signal. The craft will be out of radio contact until it reaches a standstill.
And all of a sudden it's bouncing and spinning and it's rolling, and you lose any capability to communicate whatsoever.
So we lose contact. You really worry whether the spacecraft has survived.
16 years of work hangs on whether in that next moment you get a radio signal or you don't.
By now, 100 million miles away on Mars, it's already over. The probe is either safely down or it's crashed. A signal is either traveling through space toward them, or it's over. All the team can do now is wait. The space probe has landed on Mars after a terrifying deceleration from 12,000 miles per hour to 0 in 6 minutes. In NASA's mission control, they're waiting for a signal to hear whether it's survived the entry, descent, and landing phase. Nervous minutes pass. Finally, at 8:51, the rover makes contact with them. Spirit phones home.
An interplanetary hole-in-one, without a doubt.
But there is still one more obstacle before the probe can start its work. Would the cable cutters that nearly grounded the probe work when the explosive bolts fired? Or would the most complex robot vehicle ever designed be trapped on its lander for the rest of time? If everything works the right way, the rover unfolds itself, deploying its solar panels and panoramic camera. The rover then sends the first pictures back to mission control. Three hours after landing, the images arrive. They are the first concrete proof that the rover is operational.
I'm sorry, I'm just blown away by this. I will attempt no science analysis because it looks like nothing I've ever seen before in my life.
But for me, it was just this immense burden being lifted from my shoulders that we would never get to Mars. You know, here was a signal from our vehicle, from the world that we had built it for the first time.
The human species got a new definition of Mars that evening. And to see those images the first time they come down, that I'll never forget that.
The very best moment of the whole mission was that first moment when we had 6 wheels in the dirt on Mars. That, to me, was the triumphant moment.
Spirit's sister probe, Opportunity, lands safely 3 weeks later. Against enormous odds, Squires and his team have landed the 2 largest and most complex rovers ever sent to Mars. The mission, to search for signs of water, has begun. Now the rovers must contend with the harsh conditions of Mars: dust storms, rocks, and craters. Avoiding all this falls to rover driver Scott Maxwell.
I have the greatest job in 2 worlds. I come in every day and I look at pictures from another world that nobody's ever seen before. It's very much like a video game. And we have a 3D copy of the rover that we put down inside that video game, and we drive it around.
Every evening, the driving team uploads the commands for the day to the rover's onboard computers. The sun gets strong enough to power the rovers for just 4 hours every day. During that time, they can travel up to 330 feet. But mostly they don't travel that far. They find an area with interesting rocks and soil, then stay to explore. Cameras on board the rovers help them avoid obstacles like rocks and craters.
As they're driving along, they can take pictures of the world and reason about what's in it. They can figure out what the world looks like in 3D and find a safe path.
Only 8 days into the mission, Opportunity rover comes across some strange rocks. They are small and perfectly round. The team nicknamed them blueberries. On Earth, blueberry-shaped rocks normally only form in liquid water. Could these be proof that there was once a lake here? Geologist Marjorie Chan believes so. Before the mission even began, she had predicted that if water once existed on Mars, the probes might find formations of this kind.
When the rovers sent back those first images from Opportunity, we saw those balls and we just went crazy.
The team is delighted. The mission to search for signs of ancient water is bearing fruit. Then comes even more evidence. The rovers discovered 2 minerals, goethite and jarosite, which could only be formed in the presence of water. After 4 decades of looking, they now had hard evidence. Groundwater did once flow over Martian rocks.
Oh, I think the evidence is overwhelming that they have evidence for water on Mars.
On Earth, water means life. If there is still water flowing on Mars, who knows what future missions might find. But water alone is not enough to get life started. That requires a complex soup of organic chemicals as well. On Earth, life started just under 4 billion years ago. And since then, our planet has become a very different place. We can't go back in time to study the conditions on early Earth, but we can still study those conditions today on another world. In the early 1980s, the Voyager probes passed Saturn, taking the first close images of Titan, its largest moon. Measurements revealed that maybe Titan's thick orange atmosphere could contain the chemical precursors for life.
In some respects, Titan's atmosphere now is like Earth's atmosphere was perhaps 4 billion years ago.
Here, tantalizingly, sitting in our own solar system, was a moon very much like early Earth. But to see how life could have started, we have to go there. If landing on Mars was hard, landing on Titan could be impossible. Saturn's moon, Titan, is the only moon in our solar system with a planet-like atmosphere. But until 1980, no one knew what that atmosphere was made of. That changed when the Voyager 1 probe flew through the Saturn system and made an astounding discovery. Titan's atmosphere contained organic materials, a lot like the ones that eventually formed life on Earth. Could Titan be at the same stage in its life that Earth was around 4 billion years ago?
Going to Titan, in some respect, is like time travel.
But reaching Saturn's mysterious moon is a challenge far greater than any mission to Mars. Getting to the red planet takes 7 months. A mission to Saturn takes 7 years. And it must negotiate not only the asteroid belt, but the 165,000-mile obstacle of Saturn's rings. In 1990, the Cassini-Huygens spacecraft was born. It's one of the most ambitious missions ever to our outer solar system. The mission came in 2 parts. The Cassini orbiter, built by NASA, will take the most close-up images of Saturn's rings. Traveling with the orbiter is the Huygens probe, designed by the European Space Agency. This will touch down on Titan, the first probe to land anywhere in the outer solar system. Professor John Zarnecki of the UK's Open University is one of the lead scientists on the Huygens probe.
Titan is halfway across our solar system, so we really were, I would say, even a little bit crazy ever to take this on.
Another member of the team has been waiting 20 years to see below the orange clouds of Titan. Professor Jonathan Lenine of the University of Arizona.
To completely understand Titan, to see what was underneath this interesting organic-rich atmosphere, it was necessary to send a probe and an orbiter.
For the design team, creating a probe for Titan is a prodigious challenge. Titan's atmosphere is so thick that we cannot see through it to the surface. Prior to landing there, we cannot even be sure what Titan is made of. Professor Zarnecki and his team design a small spike that would penetrate the mysterious surface on landing. The spike is the very first instrument to touch the surface of Titan. It sends its data back to Earth for analysis. In the laboratory, scientists compare the electrical signature of different surfaces, some soft, some hard, giving them a wealth of data.
We didn't know if it was solid or liquid. It was that bad, our understanding or our knowledge of the surface. We had no idea if we'd float on liquid methane or we'd thud down onto a hard, icy surface.
On October 15th, 1997, after 7 years in construction, the Cassini-Huygens probe is ready for launch. The spacecraft is enormous, the size of a school bus. At the time, it took the largest rocket in NASA's arsenal, the huge Titan 4B Centaur launch vehicle, to send the probe into space. The rocket weighs 1,000 tons. It's the height of a 22-story building, and at 4:43 in the morning, the final countdown begins.
T-minus 10.
Across the world, 8,000 engineers and technicians hold their collective breath.
About 12 minutes.
The previous launch of a European space mission called Cluster saw the rocket explode shortly after takeoff, destroying the $500 million spacecraft and shattering the dreams of hundreds of scientists. All the team can do is watch and pray. Professor Marty Tomasco of the University of Arizona built the camera that would take the first pictures of Titan's surface.
It was only about the 4th launch of a Titan IV for a civil space mission, And I believe the launch before us blew up on the pad.
I was such a basket case during the Cassini launch. Many people have lost spacecraft payloads work because the rocket blows up.
5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn.
Right on time, the rocket takes off.
Pitch program is in, roll program is in.
The launch goes without a hitch.
We have cleared
the rocket rises high above the platform. Cassini's perilous 7-year journey to Saturn has begun.
Turn is separation.
The spacecraft uses the gravitational pull from Venus, Earth, and from Jupiter to gain enough momentum to reach Saturn. When the probe approaches a planet, the gravity of that large body takes over, propelling it past, this time faster. Engineer on flight operations on the Cassini-Huygens mission is David Duty.
When a spacecraft flies by Jupiter to get a gravity assist, it's taking some of Jupiter's momentum to speed up the spacecraft.
But along the way, there are many dangers.
There's always the chance of micrometeoroids, small dust particle grains of sand, which of course are traveling at thousands of miles an hour.
The next obstacle is the beautiful but deadly rings of Saturn. This is the largest space probe ever built. Now it must make it through an area littered with rock and ice to Saturn's moon, Titan. The Cassini-Huygens space probe is on a 7-year journey to Saturn. If all goes to plan, Huygens will be the first probe ever to land on a body in the outer solar system. For the mission to succeed, the Huygens probe must send its data from the surface of Titan back to the orbiting mothership, Cassini. Cassini will then relay the information to Earth. Before the fixed communication system can prove its worth, Cassini and Huygens have to overcome one last deadly obstacle: Saturn's rings looming on its horizon. These rings are made up of billions of pieces of rock and chunks of ice, from the size of a dust grain to the size of a house. Saturn is 95 times as massive as Earth, and its enormous gravitational field captures any passing objects into its orbit to form the rings. These rings are wide, nearly 165,000 miles, but very thin, only about half a mile of beautiful but deadly rock and ice. To reach Titan, Cassini-Huygens will have to fly right through the gap between the 5th and 6th, or F and G rings, using its main antenna as a shield. One miscalculation, and the huge probe will smash into a million pieces. June 30th, 2004. Cassini prepares to enter orbit. Millions of dollars and entire professional careers are on the line. Mission Control waits for a signal that the probe is still intact and operating. Cassini rotates its giant antenna and heads toward the gap. Mission Control waits nervously for the signal that the 6-ton, $3 billion spacecraft has survived. 19 minutes later, a signal comes through.
Johnson just reported a signal. We've survived the ring plane crossing through the F and G ring.
The probe has survived, though not completely unscathed.
The Cassini spacecraft was hit about 500,000 times as it went through the ring plane at that point. Fortunately, all of the hits were of tiny particles the size of smoke particles.
Despite the hits, the probe is still functioning. It's time for Cassini to release Huygens for its mission to Titan. On January 14th, 2005, Huygens enters the thick, foggy atmosphere. On board, a camera is set to take the first ever pictures of this mysterious moon.
This literally was the culmination of, for many of us, more than 15 years of work. It was success or failure in a matter of just a few hours.
I had had nightmares for many years that this just wouldn't work and we would not get a single piece of data from Huygens.
Unlike the Mars landers with their airbags, the Huygens probe has only parachutes to slow down its fall. There are 3 of them, and they should give the probe time to take the first pictures of Titan from below the clouds. But danger heightens as re-entry and touchdown approach. It will be 4 hours before Huygens can contact Cassini to confirm it is safely on the surface. Until then, the team can only hope for the best. But unexpectedly, one of the telescopes tracking Cassini picks up a signal direct from Huygens itself, just an hour after the probe has landed, 3 hours before Cassini can relay the signal to mission control. The signal is incredibly faint, but proof that Huygens is alive and well on the surface of Titan.
The strength of the signal received on the Earth from Huygens was unbelievably small. I think it's something like the equivalent to putting a mobile phone on the surface of the moon.
Huygens was alive and transmitting directly back from Titan, the first probe to land on a celestial body in the outer solar system. Huygens has survived the landing, but the real data signal is still to come.
I'd been preparing for this for many years, and I think because one always knew that it might fail, we might receive no data, I'd sort of prepared some sort of emotional barrier in case it didn't work.
3 hours later, and 7 nail-biting minutes after Cassini was supposed to transmit, Mission Control begins receiving data back from Saturn's most extraordinary moon.
Here, for about 2 minutes, were these thumbnail images of Titan's surface, the first that any human eye had seen of the surface of Titan, coming at you 1 every second. And so it was this incredible emotional experience, and people were screaming as these pictures came through for about 2 minutes.
The first pictures through are of Huygens' descent. The landscape looks similar to parts of our own planet. The camera has less resolution than a modern cell phone, yet the images are detailed enough to show a rocky landscape, but with a difference.
We're pretty certain that it's the equivalent of sand or gravel. But in the case of Titan, the sand and gravel is not made of rocky material, stony material like it is on the Earth. The bedrock on Titan is ice.
Back in space, Cassini's special infrared cameras reveal that Titan's surface has undergone geological processes similar to those on Earth, lava flows, and even volcanoes. Cassini is set to continue gathering data until at least 2008. In that time, scientists are confident they will learn new and extraordinary things about this strange world, teaching us more about the chemicals that gave rise to life here on Earth almost 4 billion years ago. Both Mars and Titan are helping us to build an even more complete picture of how our solar system formed in the first place. And there's more to come. NASA is studying future missions to Mars, including the possibility of collecting samples and returning them to Earth. There is even an idea to send an airship-style probe back to Titan to travel through its atmosphere, gathering data. Probes such as Cassini-Huygens, Spirit, and Opportunity are the pinnacle of human technical achievement. Through them, we have learned secrets that would otherwise have remained mysteries forever. And where probes go today, Perhaps people will go tomorrow.
One of the things that we're doing, I hope, with this mission is exploring the next generation of scientists and engineers who are going to go to Mars and do stuff better than we were able to do it. Okay, because they saw this on television, because they saw these pictures on the internet, and they thought, hey, that's neat. I bet I could do this. I bet I could do this better.
Wherever future generations may go, whatever they may achieve, one thing is certain. Probes will go ahead of them, revealing new knowledge and new mysteries. And perhaps one day, there will even be a probe that delivers the ultimate news. We are not alone.